Have you ever wished your phone could bend without breaking? Or that your fitness tracker could wrap perfectly around your wrist like a sticker? Well, the secret to making these cool ideas happen is not just a flexible screen. It is also a flexible battery. Batteries are usually hard, heavy boxes. They give power to our toys, phones, and computers. But what if we need power for things that are soft, curvy, or can be folded? That is where bendable batteries come in. They are a new kind of power source designed to twist, stretch, and bend, right along with the devices they are inside. This amazing technology is changing how we think about where and how we use electricity. To understand why bendable batteries are so special, let's think about a normal battery. Inside a typical battery, like the one in your TV remote, everything is rigid. There is a hard outer case that protects the important parts inside. These parts, called electrodes and an electrolyte, are also stiff. If you tried to bend a regular battery, it would likely crack or break. This could be very dangerous, as the chemicals inside can leak out. So, for a battery to be flexible, every single one of its components must be able to bend and stretch safely. It is a huge engineering challenge that scientists are working hard to solve. The need for this kind of power is growing every day. Think about smart clothes that can monitor your health. A shirt that checks your heart rate would need a power source that moves with you as you walk, run, or stretch. You would not want a hard, clunky battery pack sewn into your t-shirt. The same goes for medical devices that stick to your skin like a bandage. These devices need a battery that is as soft and flexible as your own skin. Bendable batteries are the key that unlocks a whole new world of wearable gadgets and futuristic electronics that can fit our bodies and our lives in amazing new ways. So, how do we get from a hard brick of power to something that can bend like paper? The journey starts by completely rethinking how a battery is built, from the inside out. Instead of a solid metal case, imagine a soft, rubbery container. Instead of stiff internal plates, picture thin layers that can slide and stretch. Scientists are exploring amazing new materials and clever designs to make this happen. It is like turning a brick into a noodle, but this noodle can power your favorite devices. This is not just a small change, it is a complete revolution in how we store and use energy. How do scientists make a battery that can stretch and bend? There are two main ways to do it. The first way is to use materials that are naturally soft and flexible. Think of a rubber band. It is stretchy because of the material it is made from. Scientists have found special materials called polymers, which are long chains of molecules that act a lot like rubber. They can be used to make the battery's container, and even some of the internal parts. These polymers can also be designed to let electricity flow through them, which is a very important job for a battery. It is like making a battery out of something as squishy as a gummy bear. Another key to making flexible batteries is using super tiny, super strong materials. I'm talking about things so small, you need a powerful microscope to see them. Two of the most exciting materials are graphene and carbon nanotubes. Graphene is a sheet of carbon that is only 1 atom thick, making it incredibly thin and flexible, but also stronger than steel. Carbon nanotubes are like tiny rolled-up tubes of graphene. When these tiny materials are mixed into a soft polymer, they create a network that can carry electricity. This mixture can be stretched and bent, and the tiny nanotubes will keep everything connected, so the power keeps flowing. The second main way to create flexibility is through smart design. Sometimes, you can use materials that are not naturally stretchy and make them act like they are. It is all about the shape. Imagine a straight piece of wire. It does not bend very easily. But if you coil that same wire into a spring or a spiral shape, it suddenly becomes very flexible and bouncy. Scientists use this same idea to make batteries. They can take thin, stiff battery components and shape them into wavy patterns, like a ribbon. When you stretch the battery, the waves flatten out, and when you let go, they bounce back. This idea of using shape to create flexibility is inspired by an ancient Japanese art form called Kirigami. Kirigami is like origami, but you can also make cuts in the paper. By making very precise cuts in a thin sheet of battery material, scientists can make it incredibly stretchable. When you pull on the sheet, the cuts open up into a beautiful, complex pattern, allowing the material to expand without breaking. This lets engineers use powerful, traditional battery materials, but in a whole new, flexible way. It is a perfect example of how art and science can come together to create something amazing. As we just learned, creating wavy, spiral, or Kirigami-inspired shapes is a clever way to make stiff materials flexible. The wavy or buckled design is one of the most common, To make this, scientists place a very thin, stiff layer of battery material onto a piece of stretched-out silicone, which is like a rubber sheet. When they release the silicone, it shrinks back to its original size, and the stiff layer on top has nowhere to go but up. It forms a series of tiny organized wrinkles or waves. This wavy structure can then be stretched out flat again and again, without damaging the important battery materials inside. The spiral design works just like a coiled telephone cord. By creating very long and very thin battery components, scientists can wind them up into a tight spiral. This makes the battery extremely stretchable. When you pull on the ends, the spiral simply uncoils, and when you let go, it springs back into its compact shape. This design is great for applications where you need a lot of stretch, like in a sleeve that needs to fit different arm sizes. It's a simple but very effective way to build a battery that can handle a lot of movement without losing its connection or its power. Of course, making these amazing batteries is not easy. One of the biggest challenges is finding the right balance. Scientists need to create a battery that is very flexible, but it also needs to hold a lot of power. Often, the most flexible materials are not the best at storing energy, and the materials that are great at storing energy are usually stiff and brittle. This is the constant trade-off that engineers face. They are always working to find new material combinations and designs that give us the best of both worlds, a battery that is both stretchy and powerful enough to be useful. There are other real-world problems to solve too. Many of the special materials, like graphene, can be very expensive to make. It is also difficult to manufacture these batteries perfectly every single time. Creating a tiny, flexible battery in a lab is one thing, but making millions of them in a big factory is a much bigger challenge. Scientists and engineers are working hard to find cheaper materials and better manufacturing methods. As they solve these problems, flexible batteries will move from the laboratory into the gadgets we use every day. So where will we see these incredible bendable batteries in action? The most obvious place is in wearable technology. Imagine a fitness tracker that is not a bulky watch, but a thin, flexible patch you can stick on your skin. This patch could monitor your heart rate, body temperature, and even your hydration levels all day long. It would be so comfortable you would forget you are even wearing it. Flexible batteries would also be perfect for smart clothing. A jacket with built-in heaters could keep you warm in the winter, powered by a battery that is woven right into the fabric itself. These are not just science fiction ideas. Companies are developing these products right now. Flexible batteries also promise to make our devices safer. You may have heard stories about phone batteries overheating or even catching fire. This often happens when a rigid battery is damaged, maybe from being dropped or bent. Because flexible batteries are designed to bend and stretch, they are naturally more durable and resistant to damage. They are often made with safer materials, like solid or gel-like electrolytes instead of flammable liquids. This means that as our devices get thinner and more flexible, their power sources will be less likely to cause problems, giving us peace of mind. The future powered by flexible batteries is exciting to think about. We could have smartphones and tablets that can be folded up and put in your pocket. Medical implants could become softer and more comfortable, conforming to the shape of the human body. Even large-scale things like solar panels could be made flexible, allowing them to be rolled up and transported easily to remote locations. Bendable batteries are not just about making our current gadgets bendy. They are about creating entirely new possibilities for technology that we have not even dreamed of yet. In the end, the quest for a perfect bendable battery is about making technology feel more natural and integrated into our lives. We want our devices to fit us, not the other way around. By ditching the rigid box and creating power sources that are soft, safe, and adaptable, scientists are paving the way for a future where technology is seamless. From smart clothes that keep us healthy to phones that fold like paper, flexible batteries are getting ready to power the next generation of innovation. The future is not just smart, it is flexible.